Good morning, family. May 28th, 2020. It is I, Mr. Romer, your intrepid instructor. A little messed up right now. I was just watching some videos about the Pennsylvania state legislature and COVID 19 and the different things going on. And I have to say that as an intelligent person paying attention to discourse and trying to listen to all the angles and all of the positions, it's very disconcerting what I'm hearing, and it causes a great deal of consternation and pause. I take it as a personal mark of pride to be as informed as possible, as humanly possible. I try desperately every day to do as much research as I can on things that I find interesting or that have a personal angle for me, as I hope all of you do. If it impacts your life, study it. If it has a great deal or a bearing upon your existence, please understand the thing. When my daughter Zara May was born, she was born with a lot of problems with her heart. She has what's known as tetralogy of Fallot, which is a genetic malformation of the heart. Her heart wasn't built normally. So the doctors had to go in and sew some things up and open some other things up and put a patch on things and basically did well, not basically, they did an open heart surgery on my newborn daughter. She was just 4 months old or 6 months old or whatever it was when she was in the hospital with this. Very young, and subsequently she's had other heart surgeries too. Um, that that's background information for me, being very, very careful with how I interact with her because of COVID-19. I practice even now when I go visit my kids. I wear a mask. I social distancing. I wash my hands. I wash my face. I do all the things that I can to keep her safe because she is someone who is immunocompromised. And if I get COVID-19 and she comes near me, she could get COVID-19. Now, I'm a 50-year-old tank. I would probably survive COVID-19. She would not. My daughter would not survive COVID-19. So I have a very particular position on COVID-19 and its effects and its transmission. And I have very little patience for people who want to downplay this so they can open up business. It disgusts me. That being said, I will do everything in my power, everything I can to practice social distancing and keep everyone, not just my daughter, Zara May, safe, but the rest of my kids who are not immunocompromised, but who very well easily could also contract COVID-19 and suffer a horrible fate. This is very real. And for anyone who says it isn't, is lying. Period. Keep safe, guys. Don't act like this can't touch you. It can. Wear your masks. Not for yourself, but for the people around you. Practice social distancing. Not for yourself if you don't want to, but for the people around you, for your grandmother or grandfather, or for new kids recently born. who are at the greatest risk of this. You, like me, might get COVID and beat it. I've always been very stout and strong when it came to handling things. I would get the flu. People would get the flu for 3 or 4 days. I'd get it for a day and grind through it. But I have to remember, not everybody's me. Not everyone is capable of muscling their way through physical ailments and problems. There are individuals on this planet who do not have that edge. And so please, just everybody stay quarantined, please. We'll get through it. It'll be good. Anyways, public service announcement. So last we checked, we did aftermarket. Oh, I have to do my thing. Oh, hello, Autobots. A reading from our book. The next one, air checking. Oh, the use of compressed air to check clutch and servo operation on transmissions during and after assembly. All right, followed quickly by air diverter. We'll do the airs, except for when we get to the equipment. So an air checking is the use of compressed air to check clutch and servo operation on transmissions during and after assembly. There's a reason for this. Air diverter valve, a valve that changes secondary airflow from the exhaust stream to the air cleaner or vice versa. This is true. Air dryer, a device fitted to compressed air lines to remove moisture. Good. Good, we can cover those today. So, air checking. Automatic transmissions use hydraulic fluid in its operation to engage solenoids to either bring gear sets into or out of play with the primary input and primary output line shafts. Now, one of the things you can do if you're rebuilding a transmission, especially an automatic transmission, you can't do this with a stick. A stick has a physical, an actual bar of steel that goes down, that moves the forks, that changes the gear position, whichever gear ring gets brought into play with the power coming through the transmission. It's an actual physical metal bar that pushes and pulls on the various forks and the connecting rods for the forks that pull and push the little gear selector sets back and forth between the gears. In an automatic transmission, there's no metal bar that you manually select gears. The automatic transmission is doing it for you. What you can do if you're rebuilding an automatic transmission and you don't have hydraulic fluid on hand is you can use air pressure, similar to hydraulic pressure, but you need a constant flow of it because air leaks out of every little tiny angle. And you use air in the line to activate different pathways that will have solenoids at the end of them. So your air is basically taking the place of hydraulic fluid in the checking. Once the transmission's back in the car, you fill it up with fluid. Then you do it with fluid. But if a transmission's sitting on a workbench, you can check solenoid activity by using an air line in one of those little silver trigger jobs that blasts air up. You just plug it in and you give it a little trigger and you see if the thing on the end clicks or doesn't click. That's air checking. It isn't just about transmissions. You can air check a lot of things. Anything that needs a hydraulic to activate, you can check with air if possible. You have to be careful with the amount of air and the flow of air. Like if you wanted to check the piston activity on a caliper, a brake caliper. Let's say you took a brake caliper and you got it in your hand. It's off the vehicle. The car's down in the shop and you're over in the workbench and you've got the brake caliper on the table and you want to see if the piston will slide in and out. Well, if your finger can't do it, let's say for whatever reason you can't use your finger to push in the piston. Well, you take a compressed air and you spin it around, you go to where the brake fluid pushes in, and you put the nozzle up and you hit it with a little bit of air and see if the piston comes out. Check movement that way. Don't use a lot of air. You don't want to blast the piston out. Pop it out. Send it. It's ceramic, so it'll chip if it falls, right? You got to be careful, obviously. You don't want to overpower things. It's also one of the things that King and I talked to you guys about concerning being kind to your tools and equipment, being respectful of the equipment itself and not treating it as all of it as an iron bar. People think all tools are iron bars. That's all they are. You can hammer them, chisel them, smash them, drop them, throw them, and it's just an iron bar. Nothing's going to happen to it. Nothing could be farther from the truth. I know equipment, digital torque wrenches. You drop a digital torque wrench, it's done. You got to send it back to be recalibrated. It's finished. Put it into the box, wrap the box up, put it in the mail. If you drop a digital torque wrench, it's done. Wrap it, pack it, send it back for recal. And they can recalibrate. That's part of. We could recalibrate if we had the equipment. We don't have the equipment. We don't have that level of expertise. There are shortcuts about recalibrating. You could, here, I'll explain. So you take a bolt and you weld it to a table. Then you take 10 washers and you put it on the bolt. Then you take a nut and you cinch it down on top of the washers. The washers act like a spring. That's all that it does. You use about 10 of them. Then you take a known torque wrench that isn't broken, that you know the value to. You set it for 50 foot-pounds. And you ratchet down the bolt until you reach on your wrench that works and is calibrated 50 foot-pounds of torque. Right? Then you take the torque wrench whose calibration is iffy, and you set it for 45 foot-pounds of torque. It's a 10% reduction, right? 10% of 50 is 5. 5 minus 50 is 45. 45 foot-pounds, 10% reduction. And you take that torque wrench that you want to check out, and you put it on the nut that's been torqued to 50, and you check to see if you can get to 45. If you can get to 45 and the torque wrench clicks or the lights come on to say, yeah, it's torqued to 45, because it's torqued to 50. So you're 5 pounds early, it'll go off. So, okay, then go set it for 47 foot-pounds. If it checks for 47, it comes on because the nut's on 50 and you're still asking just for 47. You go to 50 and you see if it, because the nut's on 50, the calibrated torque wrench also, made sure and set it to 50. So now the torque wrench in question also set for 50. It's going off. Now here comes the fun part. You want to make sure that you're not getting a false positive reading, meaning set it for 60. Set the new torque wrench for 60 foot-pounds. And here's the thing. If you set it for 60 and you rotate your torque wrench around and it says, yes, it's torqued for 60, when in reality it's torqued for 50, then you're out of calibration. You have to reduce it. But if it takes it and it sets it to what it says for 60, you have a new value set because you've now tightened it up and the torque wrench is saying it's at 60. So now you take that torque wrench off, the one in question, and you take the torque wrench that's good, the one that says, yeah, this is a working one. I know the numbers are good. You put it on, and now you, pound by pound, creep up onto the new torque value of the nut. And if you can make it to 60 pounds and it goes off, you know that both the unit that is calibrated is truly calibrated, and the torque wrench in question is also calibrated. So that's how you do it, taking a torque wrench that's out of calibration and checking to see if it really is out of calibration, one that you've dropped. Anyways, old-timey style of checking. So air checking, yeah, you can use air to cause a poppet to come out. You can use it to check a line for leaks. Air checking can be done on a whole bunch of things. Be inventive with air checking. Servo motors or lift gates. People who manufacture pneumatic style lift gates that will check the activation and operation of a motor or switch. They just hook an air line to it, and it causes whatever it is, like a door, to open up if it's a hydraulically or pneumatically activated door. There's all different kinds of things you can do with an airline to check operations of things. Just got to be inventive and understand the mechanics of what you're doing. You're using air in place of hydraulic fluid. Make no mistake, when you're done checking the thing, you got to put it all back together again and fill it with hydraulic fluid and then bleed out the air bubbles. Hydraulic fluid doesn't work when there are air bubbles in, because air bubbles can squish. So you don't want no air bubbles. So after you air check something, especially a transmission, ensure that the air bubbles have been removed when you fill it back up. You want to cycle the system and get hot hydraulic fluid flowing through the different lines. But that's in a different area. We won't worry about that right now. The next thing we'll talk about is an air diverter valve, a valve that changes secondary airflow from the exhaust stream to the air cleaner or vice versa. Air diverter valves, from what I remember, were big in the late 60s, early 70s. And they were part of the smog campaign. A lot of anti-smog devices were, and believe me, I love the fact that we have the EPA. I love that we have CARB, California Air Research Board. Pollution is a very real thing. Exhaust pollution is a very real thing. I love the fact that engineers are every day coming up with new and inventive ways to minimize and diminish the carbon footprint of automobiles, and to reduce the harmful gases coming out of tailpipes of cars. To anyone who says, oh, it's not that dangerous, exhaust gas is just, nitroses and oxides. And I was like, okay, so go ahead and get a gas mask, get a hose, connect the hose to the gas mask and stick it over the exhaust pipe. Let's see how long you last. Exhaust fumes are dangerous and deadly. Yeah. So, air diverter valve. The concept of an air diverter valve is it changes the secondary airflow from the exhaust stream to the air cleaner, or vice versa. And it was a way of I don't want to say cleaning up, but it lowered the numbers of the noxious fumes in exhaust pipes coming out of the engine. So back in the day, motors were not very efficient. They were carbureted. A lot of them ran rich, which means there was gasoline making its way down, unburned fuel making its way into the exhaust, where it was being boiled off, and the fumes and it was just horrible. It was a disgusting mess. So certain automotive manufacturers used to have smog pumps, which were just glorified air pumps that would either pump extra air into the exhaust stream to artificially lower the numbers of the amount of bad fumes in the exhaust. It just changed values. Or some of the more inventive things were exhaust gas recirculation systems, which we still use today, which siphon off a percentage of your exhaust and reintroduce it back into the airstream going in to the intake manifold. You go, Mr. Romer, why would they do that? Well, one of the things that they're trying to do is siphon off a percentage of the exhaust airflow so that any unburned fuel can be burned in another combustion process as these exhaust fumes are rerouted through the intake and reburned. You're getting another crack at reburning some of the exhaust fumes, excuse me. And vice versa, there were systems in place where exhaust systems could get clean air from the air cleaner, excuse me, to help. If there wasn't enough air, it couldn't burn off all of the exhaust fumes post combustion event. There are a lot of engines out there that are not efficient. As a matter of fact, a funny story about the rotary motors is that rotary motors often run wet, very rich. If they had one pre-detonation event, the rotor is blown. The seals are gone. Reciprocating engines can deal with a lot of engine knock and not suffer a lot of catastrophic damage if you're not pushing that hard. But the rotary engine, through its design, one knock event, one. It doesn't matter which lobe, doesn't matter. One pre-ignition event, you've blown the motor. What happens is you blow the seals out. The seals get burned and they no longer seal, and it's like losing compression through your whole engine. So it's done. You got to tear the motor apart, put new apex seals on it, new side seals, rebuild the motor, put it back together. Granted, it's easy. It's not hard work. There's no machining involved. It's just pulling a strip out and putting a strip back in. But it's the fact that you got to tear your motor apart and dig it around and all that you've got to do. So rotaries are notoriously run rich, or what they call wet. And this is because they never want to have a pre-ignition event. They always want to run it never lean. You don't want to lean out a rotary motor. You want to run it as rich, as fuel rich as possible while still maintaining a good combustion event. So what does that mean? That means that unburned fuels make their way into the exhaust area of rotary engine cars, so that rotary engines are notoriously bad for emissions. Like, it's part of owning a rotor is you're going to have bad emissions. You just can't get, it's part and parcel of it, period. Because of that, because there's a lot of unburned fuel in the exhaust gases of a rotary, people have taken to putting their catalytic converters or their first expansion sets, kind of like a resonator, not quite a muffler, but more in tune with like a resonator pipe right before their catalytic converter. And those things get cherry red, super hot, because what's happening is the exhaust gases that make it through the combustion event finally light off, and they light off in the resonator or the pre-cat or in the catalytic converter itself. And those things glow cherry red, which interestingly enough is one of the reasons why turbochargers work amazingly well with rotary applications. Because not only is it getting exhaust gases, but it's also getting exhaust gases that are burning yet more fuel that didn't burn in the combustion process, and it's burning it in the exhaust headers and in the system prior to the turbine hot side of the turbo, and so it really, really, you get a rotary motor on the pipe, man. That thing spools up like a demon. Woof, spools up quick. I'm sure with the new technologies coming out, rotaries don't have to be run so rich, and so their exhaust gas temperatures, the EGTs, won't be so high in a rotary. They'll be more in line with what's normal in the industry for normal piston operated vehicles, and the numbers will come down. But early 80s, early 90s Wankel rotary engines always had the notoriety of being, first off, you got to run them wet so they don't knock, and secondly, because they're run wet, there's a lot of unburned fuel in the exhaust that does burn. It does. I don't want to say it flames, but it definitely burns a little bit. It flames, I guess, but not in a popping fashion. More of a controlled burn that literally cherries the exhaust manifold and the pre-cat and the cat. So if you stick a turbo over there, they run real good when it's warmed up. Anyways, air diverter valve. And then the ECU controls the air diverter valve. Whether it wants to add more air down to the exhaust because the engine's running really well and it can afford to throw a little bit of fresh air towards the exhaust to give it good numbers, or running the reverse of it where it needs to pull hot exhaust up into the intake manifold. Maybe it's a super cold day and it wants to warm up the engine. There's recirculatory, there's coolant recirculation systems. Heck, even on my Miata, I remember having coolant lines up in the head when it's a really cold day. Because remember, guys, an efficient engine wants to be around 200 degrees. 200. 200 is the number. Wants to be 200 degrees. And everything and anything it can do to help itself to get up to that high number, 200 degrees, would be great. So if you want to take exhaust gases and route them up through the intake to help increase the heat, so get your motor running up into its efficiency area of 200 degrees, great. You can do that. But with advent and technology, they got other ways now. Air diverter valve, you'll also see it in diesel engines. Remember, diesel engines, they don't run on a throttled intake air charge. They have no throttles at all. They're just open intake. They run on the amount of air that a cylinder will accept based upon how much diesel fuel gets squirted in there. That's all. They put turbos on diesels because you want to be able to stuff as much air in as possible so that however much diesel they put in gets burned. But diesel just operates on a different methodology. It's not a spark based, it's compression based. Where the air fuel mixture in diesel, when it gets to a certain point of its compression stroke, it auto ignites. So it's a very measured and controlled amount of fuel. It's high pressure, actually, really high pressure. 60, 70,000 PSI, some stuff like that. Some horrific number that, and this is a true story. If you're a diesel tech and someone says you got a fuel leak in the high pressure injector lines, you don't stick your fingers in there. Just, what happened? I was checking for leaks and lopped it right off. It does. They have special tools for that. Yeah, called a screwdriver. Wiggle it around, see where the leak is coming from. You can feel it. It's like a massive pressure. It's like a pressure hose. It's like water at that point. But it's water that cuts. Let's see. Air dryer. That's simple enough. A device fitted to compressed air lines to remove moisture. We see them. They're those little clear cups with a little bit of bunting or maybe a vinyl liner or a mesh. What happens is air comes through in that container. It allows the air that's running through the airline to actually expand a little bit, and that expansion causes condensation, and that condensation in that small little bell jar container is that flow area will accept moisture running through it. Or if there's moisture just being in the line, it'll come through the line like liquid in a straw. It'll get to that open area and just drop out. Just gravity pulls it down. And so moisture and little water droplets get put down into the little bell jar. We'll show them around the shop when we see them. That's one of them, an air jar. A more aggressive form you could have, that's passive. Passive's okay. Active is nice, where it actively has heaters and condensers, and it's like basically an air conditioning system for the airlines, where you have to plug it in. It needs its own power source, and it's an electric motor that runs a compressor and a chiller, an evaporator, and a heater. Goes through. It sends the air in a hose and a pipe through all of these different areas, and then the moisture is extracted in this like this. It looks like a little radiator area. It's really cool, and you got to empty that radiator out, every couple of days as the moisture condenses in it. In the condenser, specifically, it's the condenser. You got to open the condenser up and empty it out. I remember I was over at OMG, Olympic Manufacturing Group, and one of the jobs I had was I had to go up on the roof because our air compressor, it wasn't this little 2-piston engine that we have in our compressor closet. It was the size of a small car or a van, like a microbus, a VW microbus. You guys know what those buses look like. Imagine that being the size of an air compressor. The compressor, not the holding tank of air, the actual compressor. It was hooked up, it was direct drive to an electric motor the size of a beer keg barrel. You guys know a barrel for a keg of beer? That was the size of the electric motor that direct drove. There were no belts. It was just a shaft that went to a twin lobe air compressor, just like a Roots supercharger. It had interlocking lobes. So the lobes would get twisted and bring air in on one side, squeeze it against the wall, push it out the other side. And the lobes were 4 feet long. They were 4 feet long, 3 feet tall, and around 18 inches in diameter each lobe. It was huge. We had 2 of them. And they were both force fed into an iron pipe, an 8-inch pipe that ran up to the air dryer system. And the air dryer system was on the roof. And one of the jobs that we had in maintenance was to go up to the condensers. We would sign it off because it couldn't be on. We would lock out, tag out the system. We would go up on the roof, and it was on every Thursday night. They did it on Thursday night because they didn't want a lot of moisture over the weekend, but they didn't want to do it on Friday because Friday they figured that we were being lackadaisical. We never were. It was always a sign-off thing. It was just when they, 20, 30 years ago when they made the schedule for it, they said, oh, well, maintenance staff will do it on Thursday nights. So Thursday nights, it was my job. I was head of maintenance at OMG of the night shift. And we would go up onto the roof, and we would lock out, tag out the air pressure system, the air pumps. And then we would go up there, and we would take what was it? It wasn't metric. It was like an inch. It's like an inch and an eighth wrench. Big, big, big wrench. And 2 of us, you would open up the spigot on the bottom. You didn't have to remove the nut. It was either on or off. It was a ball valve. The spigot was a ball valve, but it had a separate nut on the bottom, so people just couldn't come up with their hands. Actually, you had to use it's like a 2.5 foot bar. Sometimes you had to muscle it over, and all the water would just come splashing out, gallons of water. And once all the air was out, or all the water was out, you closed the ball check valve back up, and you went downstairs and you pulled it out of Loto at lockout, tag out, re-energized the system, pressurized it back up, went back upstairs, make sure it wasn't leaking, and then put your name on the paperwork. Look at me talking about my old job. But anyways, that's what an air dryer does. It's like a hair dryer for your hair, if you have hair, but for pressurized airlines. So, is that good for today? I think that's good for today. Air checking, air diverter, and air dryer. Everybody ready? No, there's more. Let's talk more. Yeah, let's talk about the last one. You ready? And it's applicable to this. It's not a tool. It's called an air gap. Now, air gap has several different things. So today we've gone air checking, air diverter valve, air dryer, air gap. I'm skipping over air drill because that's a tool. It's just a drill that runs on pneumatics. We're not talking about it. But we will talk about an air gap. And the reason why we're leaving drill is because we have air drill, air hammer, air impact wrench, air nozzle, air ratchet, air spring, air supply, air switching, air conditioning. So there's a lot of airs, and we'll get to them. But right now, we're staying in the realm of air checking, air diverter valve, air dryer, and an air gap. What's an air gap? I'll read it. The space or clearance between two components. Excuse me. I hiccuped. The space or clearance between two components, such as the space between the tone wheel and the pickup coil in a wheel speed sensor. Air gap can be found in many places, and it's really important. The first one I want to talk about is not this tone wheel. The first place where air gap is incredibly important is in a spark plug. The gap between anode and electrode, that distance is super critical when you're developing an engine or if you're modifying an engine. Spark plugs are rated not just in the amount of voltages and amperages that they can handle, and that's usually dictated by the amount of porcelain and the amount of metal that they're manufactured with. You take a spark plug from a motorcycle or a lawnmower engine, they're small, tiny. They don't need a lot of electricity. You get the spark plug for a Ford 460 truck engine, a big spark plug. The older motor, the big motors needed huge pistons in there. They need a big pop. So you're going to throw a lot of electricity at it. Those are the outliers. Most spark plugs in the automotive field are going to be in a general size range, but they're in different heat ranges. This is the amount of heat that each spark plug operates in. And they do operate in separate heat ranges. If you run a naturally aspirated car, you can have a hotter spark plug. But if you run a turbocharged or supercharged or nitrous engine, you want to run a slightly colder spark plug. We'll talk about spark plugs in another day. We're talking about air gap. So within the spark plug, within that gap between anode and electrode, if the gap is too tiny, the air gap is very small. And when the air gap is really small, it doesn't take a lot of electricity to jump that gap. And because it doesn't take a lot of electricity to jump that gap, the amount of spark that it generates is less than overwhelming. It's the same amount of electricity, but because the gap is so small, that electrical connection, that little miniature lightning bolt that goes through, doesn't get a chance to heat up the air around it. It doesn't impact the air around it quite as much as if the air gap was massive. Same amount of electricity, it's just more of the lightning bolt is exposed. So when the air gap is super tiny, it's easier for the electricity to flow through that small air gap, because remember, air is an insulator. It's not a conductor. Is it a perfect insulator? Not at all. That's why we have air gaps. Electricity can bridge that gap. If there's enough pressure, if there's enough voltage and amperage in it, you can bridge that gap for sure. How much electricity required is the shorter the air gap or the smaller the air gap, the less amount of electricity you need to bridge it. Once it's bridged and the electricity is flowing from electrode to anode, if the gap is too small, there's not enough surface area of the little lightning bolt to effectively light off an air-fuel mixture in a car. The flip side is, oh, Mr. Romer, why don't we just have everything 1 inch anode to electrode? And then it becomes an area of, well, that gap is too big for the amount of electricity to jump. It takes too much energy to jump that gap. And you'd end up with a lot of erosion. So let's say you can get enough electricity to jump that massive gap. An unintended consequence is you also get anode or electrode burn. If you have to push that initial amount of electricity through, it starts to eat away at the metal and the heat, and you end up with something that's wicked hot, and it starts to eat away at the electrode to the point where if you have a misfiring car and it's too hot, I've seen spark plugs that electrode was a nub. It was a nub. Okay, so in order for you to get the most efficiency and the most life out of your spark plug, you have to be very aware of the spark gap. You want it big enough so that the little lightning bolt that goes from electrode to anode is sufficient enough to ignite the air-fuel mixture in the piston where it resides. You don't want it too small so that it doesn't combust properly, or it doesn't ignite it properly, and you don't want it too big where it puts a strain on the electrical system to push the gap and therefore erode the electrode, and you end up having to replace the spark plug. And you don't want it too wide, because if it's too wide, when you can't jump the gap, the spark plug won't ignite at all. So you have to be there's a lot of variables in creating the proper spark gap. Now, back in the day, we used to get our spark plugs and we'd have to air gap them ourselves. But now most spark plugs are pre-gapped from the factory. They'll have it written 0.040, 400s, if you want to go to 500s or 300s, depending on what the gap is, what the OEM gap is for that engine. It'll come from the manufacturer pre-gapped. And you check it. You get a new spark plug in it. It'll be good to get one of the air gap wheels. It checks the gap between the spark plug anode and electrode. So you mind the gap in that regard. Another air gap is the clearance between a tone wheel and the pickup coil. So the tone ring doesn't actually make a sound. Doesn't sit there in your wheel hub area going, ooh. It doesn't do that. Bad wheel bearings do that. No, tone rings are a metal. It's like a bracelet that is attached and spins with the wheel, and it has little notches on it. Except, excuse me, one of the notches is missing. It's just the reset for the. It's a timing. Some tone rings don't have timing. They just operate purely on how many bumps go past. Tick, 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 tick. Now you guys know that a tone is nothing more than a series of pulses. So I can take this brush and tap on my computer. nice and slow, that repetitive rate of 1 pulse per second, if I sped it up and I just started really going faster and faster and faster and faster and faster, it would actually turn into a note, a pulse frequency. And the lowest notes are measured in hertz, HZs, and the highest ones are in kilohertz, thousands of pulses per second. Dogs barking. So, how does a tone ring work? A tone ring sits next to a magnetic pickup, little magnet hooked up to a couple of wires. And the fun thing about a magnet is, if this is my magnet and this is a metal thing with a couple of sensor wires hooked up to the magnet, anytime something metal passes by, the magnet is attracted to it. That attraction of magnet to metal object creates an electrical signal inside the magnet. It doesn't develop power. That's not what it does. You don't get energy from it. But what you do is you can sense, if I can put, say, 1/10 of 1 volt of electricity and I route it through this small earth magnet, anytime something metal comes near it, it changes how the electricity flows through the magnet. What happens is all of the molecules inside of the magnet, they line up and aim towards whatever metal comes walking by. And it's that lining up and aiming of all of the molecule spins inside of the magnet that actually change. If I feed it 1/10 of 1 volt, coming out might actually be 1/12 of 1 volt. Not a tenth, but a 12th. A little bit of electricity gets lost because the electricity doesn't have a straight pathway through. Now it's got to wiggle its way through all of these molecules with their spins being aligning on this. And it's that variation of electrical impulses through a magnet that every time on the tone ring, anytime one of those metal nubs goes by, this magnet goes, I can sense it, I can sense it, I can sense it. I can sense it, I can sense it, I can sense it. Right? And all those little molecules with the spins on their atoms aligning with the metal that's going by, like, ah, ah. Right? It does that constantly. What it does is we measure the value of the electricity coming out. And so if a metal object is near the magnet, it lowers the output voltage, and we can measure it. And that measurement looks like, on an oscilloscope, a little pulse, or it's actually a dip. And if you invert the dip, then it becomes a pulse. It's just a way of expressing it. So you end up with this little spike in voltage usage, right? And then the computer then assigns a value to that pulse, how tall the pulse is, its amplitude, and its frequency, how many times it happens a second. Amplitude is the volume of a thing, how loud it is. Right? And frequency is how many times a second, like a metronome. If that happens a lot in a second, the tone you get is here. Let's experiment. If I took 1 pulse, and I made it happen 10 times a second. Hold on, let me open up my thing and get to where's my tone generator? I don't have it anymore. That's sadness. I don't have it. I can download one now. Take a minute. Let's take a minute. Let's tone generator. All right. And I know I messed with this before in the whatchamacallit. In class, we talked about tone generators. So a tone generator just takes a pulse. There, look, I even tone generator. Ooh. Yeah, let's do this one. It's the first one that came up. And there's different ways of creating tones. And so while we're doing this, let's go back to the original process of air gapping. So an air gap within a tone ring and a magnetic pickup, you need to have the ring as close as possible to the magnetic pickup, or in this case, the magnetic pickup needs to be located as close to the tone ring because the tone ring's position doesn't change. It sits on it can sit on a drive shaft, it can sit on a hub, it can sit on the bearing surface. Usually tone rings are on the back side of the bearings. So as the bearing spins, the tone ring has that you can put in a secure location, let's say off of the brake bracket. You can hang a tone ring, or excuse me, you can hang the magnet on the brake bracket and aim it at the tone ring that's sitting at the back side of a wheel bearing. Let's make sure we're downloading. Open. Good. Hertz. HZ. I don't know a lot, but what I do know, I know. And so you need to have the magnetic pickup for as good a signal as possible, as close as possible to the tone ring without touching. And most manufacturers will give you a figure of how many tenths or hundredths of an inch away from the tone ring you have to have your magnetic pickup. And you'll have little feeler gauges that you can slide in between. So the best, believe it or not, the best isn't too close. You know, you don't want it wafer thin away. You want a little bit of a distance. You want to be able to make sure that junk doesn't get caught in there between the two, because then you get problems. So there it is, frequency generator. No, that's 1 hertz. This is what 1 hertz looks like. Bum, 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 bum. Right? 1 click per second. Let's bump it to 9 clicks a second. Still don't hear it. Here comes 70. Still don't hear it. Let's go to a square wave. Oh, now I can hear it. Okay, perfect. This is 2 clicks a second on a square wave generator. Tick, 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 tick. Let's move it to 6. That's 6 clicks a second. Here's 13 a second. Here's 50. Now these are just clicks, but the clicks sound so close together that it develops a tone. 399 clicks a second gives us that tone. So when we talk about a tone, that's 1. That's 1,593. Do you hear the tone? You get enough clicks together in rapid succession, your ear cannot differentiate the clicks anymore. It hears the tone. And the same can be applied for computers, for instruments, electrical, mechanical. It's a tone. That's a square wave tone. I wonder what would happen if we created a sine, a pretty sine. Oh, it's so much prettier. You can whistle it. That's neat. There's also sawtooth and triangular. That's just how that click is represented. I don't want to get into that right now. So the air gap is important in a tone ring generator. That was neat. You guys can do that. Go into your phones, go to Play Store, it's free, and download Tone Generator, Tone. All right. So air gap. Air gap's important for the magnetic pickup. It has to sit close enough to the tone ring or the ring with all the notches on it so that it actually can read the notches as they go by. It magnetically sees the notches go by. It's not seeing with eyes. It's seeing with a magnetic pickup. But not too close as to either have the magnetic hit the ring and the tone generating teeth, or not too close where even the small amount of dirt would get stuck in between and foul the readings up. Because it can. Because dirt often has little bits of iron in it, and it would throw the value of the magnet off. And so instead of it receiving, with no metal near a magnet, if I threw, let's say, 1 volt at a magnet, and if I brought metal near the magnet, the discharge wouldn't be 1 volt, it would be 0.9 volts. Just inventing a figure. But if you got a piece of dirt on it, that had a little bit of metal in it, all of a sudden that magnet always has a little metal near it. And so all the time, if you're feeding it 1 volt, it might say, well, I got 9.5 volts, so I think the tone wheel's moving now. And it might throw the reading off. Not enough so that the car doesn't work, but enough so that things don't make a whole lot of sense sometimes, and you'll get error codes. Like, I know it's moving, but it's a weird value. We're not used to it. So go check it. And sometimes it's the magnet's too close, the magnetic pickup's too far away, and it's not seeing it well, or there's junk on the magnetic pickup and you got to clean it off. All those things can give you bad values, which the computer then can't extrapolate any information from. It just goes, I'm getting numbers and they make no sense. So you want to not confuse your engine computer. So you got to make sure that air gap is perfect and the magnetic pickup is perfectly clean and the tone ring is clean. Air gap, air check valve, using a pneumatic line. Pneumatic means air, pneuma, air. It's like when you have pneumonia, your problem with your air, your lungs. So pneumothoracic means doctors who deal with your chest and lungs. That's all that means. Pneuma. Spelled P-N-U-E-M. Or P-N-E-U. I have some research to do. I need to spell. Wait, I'll do it right now while I'm next to you. Ready? We'll research it together. P-N-U-E. P-N-E-U. Yep, P-N-E-U. That's it. Same thing for pneumonia or whatever it is. P-N-E-U. That's an hour. Everybody, high five.